Physics principles and figure skating. Ba-dum-bam. Disclaimer: anything shown throughout this video I advise not to recreate. This is all for personal research. Anything performed myself is only out of interest and to include as real-world examples. In today's video, I'll be talking about angular momentum, friction, real-world case studies, and real-world examples included throughout the video. Angular momentum is the measure of an object's rotational motion, defined as the product of its moment of inertia and angular velocity. This can be shown in the formula of angular momentum equal to moment of inertia multiplied by angular velocity. Similarly, the conservation of angular momentum states that the angular momentum of a system always remains constant unless a net torque is acting on the system. In the concept of figure skating, this means that if a figure skater wants to keep spinning at the same rate and in the same direction, unless something else forces them to change. In this next clip, I am producing a visual attempt of angular momentum. As you can see, I begin by gaining momentum and then swiftly pulling in my arms to increase the speed of my rotation. Friction is the force that arises when two surfaces are in contact with each other. It is commonly assumed that figure skating boots, or just regular rentals you get at the ice rink, are like knife blades, which is incorrect. In fact, the only reason why you are able to glide on the ice is because the blade itself has a concave structure. This concave structure is what allows you to steadily balance on ice. The sharp ends of the concave structure are known as edges. On the edges, higher pressure is due to entire body weight being held on a narrow surface area of the blade. Do you ever wonder why a trail is left behind when you skate? Well, this is due to the pressure of the blade causing a water bead to form in the concave area, which instantly freezes. The image shown shows the direction of motion and use of human mechanics in order to glide on ice. In this clip, I am using one of my legs as an indication for my direction and using my other foot, which is perpendicular to my other, to push off using the inner edge. In 2025, two Japanese researchers, Mizuki Yamamura and Shinji Sakurai, published a study that tried to understand that single second. They compared 6 different types of jumps and movements figure skating. They measured angles, velocities, and forces. In 2007, two Italian researchers, Federico Fontanelli and Alberto Minetti, published a study with the sweeping title Human Locomotion on Ice, the Evolution of Ice Skating Energetics Through History. It sounds technical, it is technical, but beneath the blade didn't stay bone forever. Across millennia it evolved, wooden platforms with metal strips, then fully metal blades, then curves, edges, toe picks, each modification making something new possible, each generation of skaters standing on the shoulders of the last. How do we understand friction without thinking about? According to Karimpa and his team, in the 2023 study, we don't rely on what we see, we rely on what we do. The research introduced the concept of unideal physicists, showing that humans need direct interaction with an object or surface to accurately judge how much friction exists. This helps explain why visual cues alone, like looking at the ice rink from slideness, aren't enough to prepare us for the reality of moving across it.